The next is this activity that I would like you to carry out. You can do it in a group or individually. Okay, again, index field 64K. There are 64K blocks. So you can split 64K, you can write it in this form. The 16 bits corresponds to the index field. Then we have the byte offset. There are 16 bytes, which needs 4 bits to represent. So we need 4 bits to represent byte offsets because there are 16 bytes in a what is it called, in a block. And then to determine the actual address width, the number of bits to represent the memory address. So we were given 1024 megabytes. So again, you can assume that different value can be given to you in the exam. So you should be able to estimate or represent this 1024 or whatever the value is in this format and calculate the bit address field size. So 30 bits is here. So 30 minus n plus m plus 2 will give you the total tag field. So m was 2 to the power 2. Why 22? Where does this 22 come from?
Like the n plus m.
So n is 16.
Yeah,
M is 2.
Wouldn't it be 4 now?
So it's 2 to the power 2. So if I were to pull this slide here, you see 2 to the power m words. So there 2 to the power how many words? 4 words, okay? So we were looking for the byte offset. 2 to the power m plus 2 is in the total number of bytes. Okay? Any other question? Yep.
Why for the memory address bits did you do 2 to the 10 times 2 to the 20? Where did the 2 to the 20 come from?
It's a mega. It's the value of mega. So mega is 10. If you were to represent mega in your numerical system, it's 10 to the power 6, right? And if you split 10 to the power 6, it's 10 to the power 3 times 10 to the power 3. But when we are dealing with 10 to the power 3 is what? It's kilo, right? But when we are dealing with binary system, you write it 2 to the power 10, right? So 2 to the power 10 times 2 to the power 10 makes 2 to the power 20, okay? Any other question? Yeah.
Can you explain the offset field again?
Offset here, this one?
Yeah.
So yeah, so how many bytes? It specifies the number of bytes in a block. It is 16 bytes. So we are talking about the byte offset, which means that how many bits do we need to access these 16 bytes individually, right? So how many bits you can use to access the value up to 15, from 0 to 15. So 0 to 15, you can use the 4 bits, right? In other words, if you were to represent it in the form of m, so you would write it like how many words are there? 16 bytes means like 4 words. So 4 words means 2 to the power 2, and plus 2 is the part which is the block offset. Sorry, byte offset. Okay, I pulled up that slide. Let me try pulling it up again here. Not this one. This one here. So block size 2 to the power m words. In that example, we have 2 to the power 2, which is 4 words, and total number of bytes would be 2 to the power 2 plus 2, okay, which is 16 total number of bytes. So here m is the value 2, and 2 is the byte offset. Okay. All right. So let's proceed ahead.